Hello everyone. Out of 4 interpolation formula, Newton's forward difference, Newton backward difference interpolation formula are discussed in the previous video lectures. In this video lecture, I am going to discuss about Lagrange's interpolation formula. In the next video lecture, I will discuss Newton's divided difference interpolation formula. To get the notification of new video lecture, subscribe this channel. Advantages of Lagrange's interpolation formula are: number 1, this formula is applicable to both equispaced and unequispaced interpolating points. In Newton's forward and backward in both the methods, we have noticed x data were equispaced. In this problem, x data are not equispaced. You look here, difference between 0 and 1, 1, 1 and 3, 2, 3 and 4, 1. So they are not equispaced. Another advantage of Lagrange's interpolation formula is that the value of x for which fx value has to be determined may lie anywhere in the interval, like at the beginning, in the middle, or at the end of the tabulated values. In this question, we have to find the value for x equals to 2, the value of fx for x equals to 2, and 2 lies in the middle of the tabulated values. This is the Lagrange's interpolation formula. Fx equals to x minus x1, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2, x0 minus x3, this whole term multiplied by y0. Observe here that in the numerator, except x0, others x1, x2 and x3 are subtracted from x. And in the denominator, except x0, x1, x2, x3 are subtracted from x0. In the second term, except x1, x0, x2, x3 are subtracted from x. And in the denominator, x0, x2, x3 are subtracted from x1. Similarly for third and fourth term. In the third term, x0, x1, x3 are subtracted from x. Here x2 is left, and in the denominator x0, x1, x3 are subtracted from x2, and the term is multiplied by y2. In the fourth term, x0, x1, x2 are subtracted from x, leaving x3, and in the denominator x0, x1, x2 are subtracted from x3. The whole term is multiplied by y3. So while we will take the first term, we have to subtract x1, x2, x3 from x, leaving x0. And in the denominator, from x0, x1, x2, x3 are subtracted. The whole term multiplied by y0. In the second term, leaving the x1 term, x0, x2 and x3 are subtracted, and in the denominator, same are subtracted from x1. The whole term multiplied by y1. In the third term, leaving x2, x0, x1, x3 are subtracted from x. Same terms are subtracted from x2. The whole term is multiplied by y2. In the fourth term, leaving x3, x0, x1, x2 are subtracted from x. The same terms are subtracted from x3 in the denominator. The whole term is multiplied by y3. So to remember, this is very easy. Now let us put all the values from the table. We have to find fx value for x equals to 2. So fx equals to x minus x1, 2 minus 1, 2 minus 3 and 2 minus 4 divided by 0 minus 1, 0 minus 3 and 0 minus 4 multiplied by minus 12 plus x minus x0, x minus x2, x minus x3. So 2 minus 0, then 2 minus 3 and 2 minus 4 divided by x1. x1 is 1. 1 minus 0, 1 minus 3 and 1 minus 4 multiplied by 0 plus 2 minus 0, 2 minus 1 and 2 minus 4 divided by x2 is 3. So 3 minus 0, 3 minus 1 and 3 minus 4 multiplied by 6 and plus 2 minus 0, 2 minus 1, 2 minus 3 and divided by 4 minus 0, 4 minus 1, 4 minus 3 multiplied by 12. If you calculate it, you will have the answer 4. Do this calculation yourself. Next question is, using Lagrange's interpolation formula, find the value of y when x equals to 2 using the following table. Work out yourself. If you have any question, please drop in the comment box. In the next video lecture, I will discuss Newton's divided difference interpolation formula.